Ambitious families invest thousands of hours and tens of thousands of dollars into high school tutoring. The current system is designed to optimize a teenager into a machine capable of memorizing syllabi and producing perfect exam responses. A 99 ATAR secures admission to elite university programs, proving a student can execute strict instructions. However, it provides no training for strategic thinking once those instructions disappear. This chart maps the educational breakdown. The flat line represents the linear, rote learning model, while the steep curve tracks the problem-solving capability the modern world demands. The shaded area represents diminishing returns, where the gap between marks and actual readiness widens. Training a student to be an efficient information processor places them in direct competition with artificial intelligence. Software now performs that specific task instantly, for free. This structural weakness fails during the first semester of university. High school provides rigid rubrics and predictable testing, but university requires students to independently manage and analyze massive, unstructured datasets. Under the pressure of this workload, students often use public AI tools as a crutch. Because these public models lack custom data architecture, they hallucinate answers, leaving the student with shallow, unreliable shortcuts instead of a functioning system of intelligence. This comparison highlights two paths. On the left, packing a heavier academic burden, hoping force of effort is enough. On the right, the architectural model. Families face a choice between adding weight to an overflowing backpack or building a better compass to navigate the future. Brute force studying hits a hard biological limit. Success in elite university tiers requires owning a custom data system that organizes academic chaos into strategy. The SciLife ecosystem focuses on architecting cognitive environments. The strategy shifts from content delivery to structural design. Operating at biological constraints allows for effortless mastery. Deep focus is an engineered state triggered by the environment, rather than a trait the student must find within themselves. This engineering begins with the private AI node. This is a highly secure, closed-loop intelligence system hosted locally in Epping, designed to handle the specific structural demands of a student's academic workload. Peer students rent temporary access to public algorithms that forget data once a session ends. The SciLife student builds a permanent, compounding intellectual asset. The private node maps research, connects isolated concepts, and organizes thousands of pages of academic data into usable, strategic structures that the student controls. This digital infrastructure streamlines data management. It provides the student with the tools required for operational independence at the university level. The SciLife architecture follows a strict requirement. Parent and child work together during this developmental window. By moving away from isolated tutoring and into a unified family architecture, the student builds permanent capability rather than temporary exam skills. Together, the family masters factorial thinking. This is the first principle's cognitive ability to map multi-layered problems, analyze how variables interact, and construct logical solutions. These digital frameworks are grounded in reality through mandatory 5-day physical programs. Local park routines are used to step away from the screen and stress test these cognitive strategies through physical movement. The software provides the infrastructure, but the primary advantage is the shared cognitive resilience built between parent and child in the real world. Immersive 5-day retreats in the Blue Mountains or Bali provide radical environmental disruption. These sessions remove the family from the friction of their usual routine. This flow protocol diagram maps the mechanics of the retreat. By removing distractions and architecting the environment, the mind shifts from scattered anxiety into sustained, natural focus. This isolation allows the family to master their private AI workspace and cognitive frameworks without daily interference. This pathway graphic illustrates the levels of commitment required, connecting the digital node to the physical and immersive programs. To protect this developmental dynamic, cohorts are strictly limited. We accept exactly 5 parent and student pairs per intake. This site contains the architectural blueprint. The window to co-learn these systems alongside your child closes once they begin their university transition. Building this shared architectural partnership creates a structural advantage for students entering an AI-dominated reality.